Hello everyone. In this video, we will discuss about what is a scheduler and different types of schedulers. So as we all know that all the programs are stored on disk and then some of the programs are loaded into the main memory, and then if it is a single processor system, one process from main memory is allocated CPU. Now the question is, who is going to decide that how many processes can be there in main memory and what all processes will be picked from your disk and loaded into the main memory? And then who is going to decide that which process will be executed next? So all this thing is done by your scheduler. So scheduler is basically schedulers are special system software which handles the process scheduling. And we have different types of schedulers. The first one is the long-term scheduler. So as we know that your main memory is small and limited, so all the programs are stored on disk, and then these programs are loaded into main memory, and depending on the number of programs there are in main memory, it decides the degree of multi-programming. So the job of long-term scheduler is to load these programs from disk into main memory. Okay, so the long-term scheduler selects a process from the disk and loads it into main memory for execution. And it controls the degree of multi-programming. Why? Because long-term scheduler is deciding what processes will be loaded into main memory and how many processes will be there in main memory. Okay, then the next thing is it executes less frequently. Now, why this is so? Because you see that long-term scheduler is just deciding how many process and what all process will be there in main memory. Suppose let's say there are n number of process on disk and only 3 process are loaded into the main memory. And then right now P1 is executing. So okay, and then let's say P1, it is a multi-programming environment, so P1 requests from some IO device, so P2 will start executing, then P3. So basically your long-term scheduler will come in picture only when one of the process from main memory will be will complete its execution, right? Because then only it will be removed from the main memory. Let's say P1 has completed the execution, now it will not be in main memory, now you have only two processes, so now it is the job of long term scheduler to pick a new process and load it into main memory, right? So the due to the execution longer interval, the long term scheduler is executes less frequently. Okay, because it is just loading the process into the main memory. So it may need to be invoked only when a process leaves the system. Now, the next point is that it should select a mix of IO bound process and CPU bound process. Now, let's first understand what is an IO bound process and what is a CPU bound process. So, IO bound process is a process that spends more of its time doing IO operation than doing some computations. And then on the other hand, CPU bound process is the process that spends most of its time doing computation instead of some IO bound request. Now, why it is important to select a mix of these two? Let's say the scheduler, long-term scheduler has selected all the IO bound processes. Now, as we know that IO bound process spend most of the time doing IO operation, and all are of the same category. Let's say P1, P2, P3 are there in main memory. P1, P2, P3, and all the three are IO bound process. Let's say P1 is executing, and since it is IO bound, so it will be busy in doing IO operations, so your CPU is idle. So let's say P2 is P2 starts executing. Now then again it will also make some IO request, and then P3. So basically the point is your all the process are busy with the IO doing the IO operations. So hence your CPU or your redo queue will be empty most of the time. Okay, and then on the other hand, if all the processes are CPU bound, so let's say if P1 is executing and it is not making any request for some IO device or disk, so since this process is executing, and then so your all the resources will not be used, the disk and the IO devices, so the system is again unbalanced. So basically the system with the best performance will thus have a combination of CPU bound and IO bound processes. Now the next type of scheduler is your short term scheduler. So now as we discussed that you have program in main memory, the programs are loaded into main memory, and this is the job of long term scheduler. Now from these processes, which process will get the CPU? Basically, that is the job of your short-term scheduler. Short-term scheduler selects among the processes that are ready to execute and it allocates CPU to one of them. So like right now, it is the job of long short-term scheduler to decide which process among these three will be allocated CPU. Now you see, so this is the job of short-term scheduler. Let's say short-term scheduler picked P1 and P1 is allocated CPU. Now suppose P1 is waiting for some other event. So since it is waiting for some other event, now we one new process should be picked. So now again short-term scheduler will come in picture, and let's say it has picked process P2, and then it is executing, and after executing it is also again waiting for some other event, so the CPU is idle, so again new process should be picked, so again short term scheduler will come in picture. So you can also see that this short term scheduler is executing so frequently, right? And this short term scheduler has to be fast also, but because if suppose a process is like, suppose if you have these processes P1, let me just write them again, P2 and then P3, and P1 is executing, let's say P1 is allocated CPU. Now may suppose P1 is after executing for some time, it is waiting for some other event, so next process will be picked. Now suppose if short term scheduler is taking too long in picking the next process, so your CPU will be idle for that particular time, which is basically time will be wasted. So your scheduler should be fast so that it can quickly pick select a process, and then the process gets start executing. Okay, then the next type of scheduler is medium term. So in some operating system, like such as time sharing system, they may have an intermediate level of scheduling, which is middle term. So basically the middle term scheduler removes the process from memory, and since it is removing a process, so it is decreasing the degree of multiprogramming, right? And then the process is swapped out. Swapping means basically you are removing the process from the memory and storing it in the disk again. Okay, so the process is swapped out, and later it can be swapped in by the medium term scheduler itself. Now why is there any need of doing this? It can be required because if you want to, like due to some memory limitations, or you want to free up some memory, so you can remove a process and then bring it back later on when it is required. Now let's have a look at this picture and discuss all the schedulers. Now you see, this is your ready queue. Now what processes will be, programs will be loaded from disk into the main memory, and hence will be ready for execution. It is decided by your long term scheduler, LTS. Okay, and from this ready queue, which process will be allocated CPU? This is the job of your short-term scheduler, STS. Now, while a process is executing, it can be swapped out, and it can be swapped in later on to like this is done by your medium-term scheduler, right? So I hope all these three schedulers are clear to you. If you have any queries, please drop them in comment section. Thank you.